Welcome to the Physics Tips for Cambridge Students YouTube channel, and today we are going to be looking at a past paper question on simple harmonic motion. This is the November 2020 paper 42, question number 4. Right, please remember to subscribe to the channel and also to hit the notification bell so that you get notified of my future videos. Without much further ado, let's get started. Now, this is the question number 4 of November 2020. A dish is made from a section of a hollow glass sphere. The dish fixed to a horizontal table contains a small solid ball of mass 45 grams as shown in figure 4.1. The horizontal displacement of the ball from the center C of the dish is x. Initially, the ball is held at rest with a distance of x, which is 3.0 centimeters. The ball is then released. The variation with time t of the horizontal displacement x of the ball from the point C is shown in figure 4.2. So the graph shown there, that is the displacement, right? The motion of the ball in the dish is simple harmonic with its acceleration given by the expression a is equal to minus g over r x, where g is the acceleration of free fall and r is a constant that depends on the dimensions of the dish and the ball. Then the first question says, use figure 4.2 to show that the angular frequency omega of the oscillation of the ball in the dish is 2.9 rads per second. Right, so what we're going to do here is to look at the graph. Now we first of all need, since we've plotted here against time, so we need to find the period. Okay, so the period will be obtained, but since our graph is starting from the maximum up to there to be a period, up to there to be a period, up to there to be a period. But our governing formula is omega is equal to 2 pi over t. So 2 pi over t is our governing formula, and we are going to write it. That's the angular frequency. Just finding something to write. So omega is equal to 2 pi over t. Now, they are, so we said they are up to there, that is a period right there, which is about 2.2. We can verify it by looking at the next one. Up to there it will be 4.4. So from there to there is 2.2. So which means our period is 2.2 seconds. Okay. Slide to 12. So 2.2 seconds our period. So which means omega will be equal to 2 pi over 2.2, which gives you 2.9 rads per second. Please remember to work in radians. Your calculator should be in radians for you to work this question. So that will be 2.9, which is about 2.866, which can be rounded up to 2.9. Right, so moving on. Use figure 4.2 to show that the angular frequency, we've done that. So then use the information in A to determine R. Now, if a system obeys simple harmonic motion, then the acceleration should be proportional to the displacement from the fixed position, which is from the equilibrium position. Also, the acceleration should be in the opposite direction as the displacement. So we can say that acceleration should be proportional to minus x, something like this. So if we are to remove the proportionality sign, you find that and put the constant of proportionality, it is the angular frequency. So it's supposed to be A is equal to a constant. Then since we have got our x and minus, our constant should be omega squared. Okay, so if it has this formula, this is the solution for simple harmonic motion for acceleration. Remember, when you're asked to define simple harmonic motion, the periodic motion whose acceleration is proportional to the displacement from a fixed point and also directed towards that fixed point, and acceleration and displacement in opposite direction shown by the negative sign. So the solution now becomes A is equal to minus omega squared x, like that. So in this case, our omega squared is analogous to g over r. So omega squared in this case is equal to g over our big R, like that. So I'm going to take it down to where the question is, right there. So we said omega squared should equal g over r. So which means, making r the subject, it's going to be equal g over omega squared. Now, since we have calculated our omega, we found it to be 2.9. So we have to use the exact value there. So it's going to be 9.81 divided by 2.86 squared. We had to round up this value. So we use the exact value in the calculation. Now, if you work this out, you find that you should get about 1.2 to 2 SF. Then calculate the speed of the ball as it passes over the center C of the dish. So let's go back to the now, observing this, you find that the potential energy here is a maximum, whereas the kinetic energy will be a minimum at this position. But then through the equilibrium position, which is that the kinetic energy should be a maximum and EP should be a minimum. And then going on the other side, you get the same as on the other extreme, where EP should be a maximum and EK should be a minimum. So right at the equilibrium position, that's where you have maximum speed or maximum kinetic energy. So to get maximum kinetic or maximum speed, V should be equal, remember V is equal to omega x. So which x now? The amplitude, which is the x naught, which is the amplitude. So that's what we use there. So back to where the question is, our V should equal, so says what is the says calculate the speed as it passes over the center. Over the center, the speed will be maximum, so which is equal to omega x naught. Some say omega A, capital letter A, which is also fine. Now, according to this question, you're told that the amplitude of the oscillation from the graph there, it is 3 centimeters, which is 3 times 10 to the power of minus 2 meters. So that's what we are going to use in the calculation over there. Okay, oh, it's overshooting. So it's going to be 2.86 times 3 times 10 to the power of minus 2. Okay, so which should give you 8.7 times 10 to the power of minus 2 meters per second. Right? Then says some moisture collects on the surface of the dish so that the motion of the ball becomes lightly damped. On the axis of 4.2, draw a line to show the lightly damped motion of the ball for the first 5 seconds after the release of the ball. Right, so light damping, this is when the amplitude, the system actually oscillates and decreases gradually in the amplitude. So we expect it to be following the same route over there, but then okay, right, so it must go, so the amplitude must die down. Oh, sorry, let me start again. So you start off at the right place there, but then the amplitude decreases. 5, let's say first 5 seconds, so we should end it right there. Okay, so as you can see, the amplitude is decreased from 3 to a certain value, decreased to this value over there, so it must decrease from there, decrease to that value, and that's it. So something like this. Okay, I think that's it. So that's the end of the question. So I hope you understand. Please let me know in the comment section whether this question was well understood. Please do not forget to subscribe to the channel and hit the notification bell so that you get notified of my future videos. Right, signing out.